Welcome to today's lesson. Today we are going to talk about isomerism in alkanes. And alkanes with more than 3 carbon atoms have the ability to form compounds with the same molecular formula but different structural formula. These compounds with the same molecular formula but different structural formula are called isomers. And therefore we can say isomers are compounds with the same molecular formula but different structural formula. Alkanes or isomerism in alkanes begins from butane, that is an alkane with 4 carbon atoms onwards. Before we look at the isomers and some of the examples, let us talk about alkyl groups. Alkyl groups. So alkyl groups are formed when one hydrogen atom is removed from an alkane. Let us look at examples. This is an alkane, and then of course we have an alkyl group. If we talk about methane with the molecular formula of CH4, if we remove one hydrogen atom from methane, we are going to have a group called, from methane we are going to have a methyl with CH3. That means one hydrogen atom has been removed. If we talk about the second member, which is ethane, with C2H6, if we remove one hydrogen atom, we are going to have an ethyl from ethane, and an ethyl is going to have the formula of C2, now H5. We can talk about the third member, which is propane, with C3H8. If we remove one hydrogen atom, we are going to have a propyl with C3H7, and so forth and so on. We can also have a butyl, a pentyl, hexyl, up to a decyl for those 10 members in alkanes. So these groups are very important when we are dealing with isomers. For example, you can be told to draw, for example, two isomers of a compound like butane. Butane has a molecular formula of C4H10. So for us to draw two isomers of butane, the first one must be drawn the way it is, that is C, that is 4 carbon atoms. Then we feed in the number of hydrogen atoms like we did yesterday or in our previous discussion. So in this case, the name is going to be butane. So the first isomer is always drawn the way it is. Then now we need to form another compound with the same molecular formula, but now we change the structure. So instead of drawing or representing all the 4 carbon atoms along that continuous chain, we can draw 3 along the straight line. Then we decide to place the 4th one here. In this case, if we feed the number of hydrogen atoms, we are going to have 4 carbon atoms and 10 hydrogen atoms. So if you look at the structure of this second compound, it has changed, and in this case now the name of this compound is going to change. The first thing we need to do, we need to identify the longest continuous chain that will determine the parent name of this compound. And in this case, along the continuous line, we have 3 carbon atoms, and therefore the parent name is going to be propane. But again, in naming this isomer, we need to recognize anything that is not along the straight line. We call it a branch. So this one is a branch, and since it has 1 carbon atom and 3 hydrogen atoms, we call it a methyl. So anytime now we are naming this compound, we should number the longest continuous chain from the end that contains the branch. Since the branch is at the center, we can begin our numbering from either side, and therefore we have 1, 2, 3. This means in carbon number 2, we have a branch known as a methyl, but the parent name is propane, looking at the number of carbon atoms in the longest continuous chain. So the parent name is propane, but the name of the compound is 2-methyl propane, meaning in carbon number 2 we have a methyl, then of course the parent name becomes propane. So the compound is 2-methyl propane. So what if we call this one A? Then we have another example where we are supposed to maybe draw 2 isomers, of, let us say, a compound like hexane. Hexane has 6 carbon atoms, then 14 hydrogen atoms in this order. So the first one will always be drawn the way it is, and therefore we are going to have C, or 6 carbon atoms. Then we feed in the number of hydrogens. So the first one is drawn the way it is. And now this one is known as hexane. Then the second one, now we need to change the structure. So instead of drawing or representing all the carbon atoms, we can decide to draw 4 or 5. Then now we can hang the other carbon atoms this way. So in this case now we can feed the number of hydrogens, and if you count the number of carbon atoms, they should be 6, and the number of hydrogen atoms will be 14. So we need to identify the number of carbon atoms in the longest continuous chain, and in this case the number of carbon atoms in the longest continuous chain are 4. That is 1, 2, 3, 4, and therefore the parent name is going to be butane, but we need to recognize the branches. So this is a branch, this is also another branch here. And if you look at the branches, they have 1 carbon atom and 3 hydrogen atoms, and therefore we call them methyls. In this case now, we need to start numbering our compound from the end that has the branching. But if we begin from the right hand side, this one will be number 1 carbon, then number 2, Then of course, if we begin from the other side again, we have 1, 2, and therefore, since they occupy the same positions from either way, we can now decide to number them from anywhere. And therefore, if we begin here, we are going to have 1, 2, 3, 4. Then in carbon number 2, we have a methyl. In carbon number 3 again, we have another methyl. But since there are 2, we use the prefix di meaning 2, so we have dimethyl. But the parent name comes from the longest continuous chain, and since it has 4 carbon atoms, the parent name is going to be butane. So the correct name of this particular isomer would be 2,3-dimethyl butane.